Hey, welcome back. Week 8, task number 2. We're going to continue with surface area, but today we're going to look at cylinders and cones. So our goal today is to find surface area, cylinders, and cones. Before we get started, just a reminder, you can find everything on Schoology. Okay, go to the geometry page. Obviously, I'm looking at the B-Day page. You'd probably be on the A-Day or Miss Tochik's. Scroll on down to week 8. There's the link to the week 8 Google Doc, which has got our introductory letter. And task 1, task 2, we're looking at task 2. All our links can be found there or on Schoology. So if you can, print out the blank notes. If you don't, just follow along. Jot it down, separate sheet of paper. There's a link here to the completed notes. Click on that. Link will open up in a new page. Area formulas. Again, we had them during the week 1 as well. Same sheet. We use those. Particular today, we're going to look at circles and sector. We'll be using those two. And there's Google Doc to the interactive. While there are specific examples, there's not as specific examples to deal with cylinders and cones, but we will be looking at the cylinder and cone 3D to net shapes that we looked at last week under nets as well. And then there's the worksheet here. I just skipped over it. Here's the link to the video. It's not there yet, obviously, because I haven't completed the video yet, but it will be right there for the video lesson, which if you're watching this, you found it. And your homework can be found week 5, 6, Schoology. It's down at the bottom. They're all in order. Week 8, task number 2. We'll talk about that later on. If you have any questions on the homework for surface area, prisms, and pyramids, remember office hours, and you can find them on Schoology. There they are. There's the direct links. No school on Monday, so there'll be no office hours on Monday. But every day of the week, there are the hours. There's the link. Join on in. Stop in and say hi for those. Remember, as we do this, you should always be writing the formula, an equation showing our work, and then we need to include units. Here again is our formulas worksheet. The two biggest ones we're going to look at today is the area of a circle, which is pi r squared, and the area of a sector of a circle, where it's a fraction of the circle, and so we're multiplying by pi r squared, but we're multiplying by m over 360, where m is the measure of the arc or the measure of the central angle here. Okay, because we're taking a fraction of the entire circle. Because we're looking at cones and cylinders. What's unique about cones and cylinders? They're bases. Okay, they all have circular bases. So if I look up here at the top, letter A, the two side by side here. The first one is the 3D image of a cylinder. And the second one is the net. Well, what's highlighted in green are the bases. There are two bases in a cylinder, two circular bases. And each of those bases have a radius, because we're going to need to know that in order to find the area of our base. The red line that joins the two, that is referred to as my height. The height is the distance between the two parallel circular bases. One other important one that's going to be today for a cylinder is, in order to find the surface area, which is the area of all the shapes that make it up, is I need to know the length of this purple segment. Well, if I look at my 3D to net image, when I unfold my cylinder, okay, take the circles off, I cut it, and I'm unwrapping the sides of it, it's going to create a rectangle. Well, the height we talked about, but what about this length at the top? Well, watch what happens now as I slide this. We're taking the length that goes around the circle here. we're unfolding that and it equals that length. Well, what is that length? Well, yeah, that's the circumference of the base. So this purple line is the circumference of the base, which is equal up there. How do I find the circumference? It's either diameter times pi, or it's 2 pi times the radius. And we have our cone. What's unique about a cone is it's only got one base. Okay? It's got one base, which are the two circles that are highlighted here in orange, the orangish bases. They're two different oranges. Okay? And both of those have a radius. Okay? Got the radius here. You see it in my base here. This blue segment here, which you see the R, that is the radius as well, and the net of the cone. Well, then we have the height. The height goes from the top all the way down to the bottom. Okay, that's the height. Do I have that in my net? No, I do not. Okay. The cone meets up at a point. That point is referred to as the apex. And actually, this point right here is where the apex would be in the net. The edge, this yellow line, is what we refer to as our slant height. Well, the slant height in the net, okay, is also equal to the radius of the sector. And the arc measure is the measure of this arc in degrees, or the measure of the central angle here. That's going to be important because when we want to find the length of the or the area of this, we need to know that angle measure. And the segment that goes all the way around here is what we refer to as it's the arc length of the sector. That's the gray highlighted. Okay, it's how long the sector is. And we've got the circumference of the base, which is circumference all the way here. So if I pop up a 3D image of our cone, as I unfold it, notice to get our net, we've got our circle, make a cut, and we create a sector, because it's just a part of the circle. And the radius is the slant height. Another image I want to show you when we get started here, and we'll refer to back to here, is what is height versus slant height? Well, in a cone, okay, the slant height goes from the apex to the outside of the circle here, okay? And as I slide me, I'm going to disappear the cone to find inside the true height. Okay, that's the height. And notice the height, the slant height, and the radius here create a right triangle. And if I spin this, it brings it all the way around. And when I spin this triangle, that's how I'm creating my cone. So remember from task number 1, surface area, it's the area of the entire net. It is the base or bases and the sides, whereas lateral area is just the area of the sides, does not include the bases. And definitions from last week, cylinder. It's a 3D object. It consists of two parallel congruent circular bases. The base has two circles that serve as its base. And a cone is a 3D object that consists of one circular base. And it's got a curved side, which when you unfold is the sector of a circle, and it meets at a common vertex, which we call our apex. Let's try some examples to find the surface area. Again, we're asking the same questions we did in task number 1. So as I look at example number 1, how many circles are there? 2. So what shape is it? It's a cylinder. So let's draw the net. So I've got a rectangle which represents the sides and 2 circles that represent the bases. If I fill in the measures, 4 centimeters is the radius of the base. So I've got the 4's labeled, and 10 is the height. It's the distance between the two circles. So if I drew in another line, right between the two circles, that is also the height because it's the same segment as the 10 on the side. But that's my height. So let's find the area of the base. How do I find, and the base is what? A circle. How do I find the area of a circle? Pi r squared. What's the radius? 4. So it's pi times 4 squared. Remember, we did talk about exact. So if I wanted to find the exact here, I would just multiply the numbers. Well, 4 squared is 16. So the exact area would be 16 pi. We can't enter that into Schoology, so we are going to find the decimal approximation. So to do that, I'm just going to do 16 times, I'm using the pi button, okay? Or you could also do pi times 4 squared if you don't want to find the exact. We get 50.265, which rounds to 50.27 square centimeters. Now I got to find the area of the sides. Well, the sides, when I unwrap it, is one large rectangle. Area is base times height. The height is 10. But what's the base? Remember, when we looked at our cylinder, this length right here, which is the base, was equal to what? The circumference of the circle. So the base of my rectangle is equal to the circumference of my circle. So if my circle has a radius of 4 pi, the circumference is diameter. So if the radius is 4, the diameter is 8, is diameter times pi, or 8 pi. So that length is 8 pi. So when I do it, it's 8 pi times 10. Again, if I want to find the exact, I would just multiply the numbers. 8 times 10 is 80. So I end up with 80 pi. If I want the decimal approximation, I can do 80 times pi, which is 251.327, rounds to 33, or I can do 8 pi times 10, and I still end up with the same answer. 251.33 centimeters squared. How do I find the surface area? Just like with prisms and pyramids, it's the area of the base. Well, I've got 2 of them, so I have to multiply the area of one base times 2. So I'm going to take 50.7 times it by 2, and then add the sides, which is the rectangle of 251.33. Multiply 50.27, I get 100.54. Add that to 251.33, and I get 351.87 centimeters squared. So all I'm doing there is 50.27 times 2. So I got the 100.54, and I add 251.33, and I get 351.87. Now we are using a rounded number here. Schoology, when you type in your answers, is set up to accept that answer with the rounded number. The other option, I don't need to do it step by step. I can just do 50.27 times 2 plus 251.33, and I will get the same answer of 351.87. Another option here is to find the exact. Well, instead of using 50.27, I would use the 16 pi plus 80. Multiply the numbers to get 32 pi. Add 32 pi plus 80 pi. I'm just adding the numbers in front, and I end up with 112 pi, which, because of rounding, is 1/100th off of this answer. And like I said, Schoology will accept any of those answers. Example number 2, I've now got the net. But what shape is this? How many circles are there? 2. So it's a cylinder. So if I draw the 3D image, I got the height of 5. It says 18 is the radius. How did I get 18 as the radius? They don't give me the radius in my net. But remember, 36 pi, which is the length of this, equaled the circumference of the base. It's the circumference of the circle. So circumference of the circle is diameter times pi. So 36 pi equals diameter times pi. Divide both sides by pi. The pi's cancel out. I get the diameter of the base to be 36, which means the radius is going to equal 18. So that's where I get the 18 from it. So finding the area of the base, the circle. Area of a circle is pi r squared. What's the radius? 18. We just found it. So it's pi times 18 squared. If I want to find the exact, I'm going to just take 18 and square it to get 324 pi. Or I can do 18 squared times pi to get the decimal approximation of 1017.876, which rounds to 0.88 in the nearest hundredth. So now we got to find the area of the sides. The sides is this rectangle. Base times height. The base is 36 pi. The height is 5. So 36 times 5. If I want to find the exact, 36 times 5 is 180, so I get 180 pi. All right, type in my calculator. 36 pi times 5. I end up with 565.486, which rounds to 0.49 square inches. How do I find the surface area? It's the area of the base times 2. So 1017.88 times 2 plus the sides, which is 565.49. If I multiply the base times 2, I get 2035.76. Add that to 576.49, which you probably could just do in your calculator, 1017.88. Times that by 2 because there's 2 bases. Plus the sides, which is 565.49. And I get 2,601.25 square inches. Because it's area, and area is always the unit of measure squared. Again, if we did look to find the exact area, the area of the base, the exact was 324 pi, so multiply that by 2, I get 648 pi, plus the side, which is 180 pi, which gives me 828 pi square inches. That's the exact. We're just looking for the decimal approximation for here, so you don't need to worry about the exact, but something nice to let you know about. Looking at example number 3. How many circles are there? 1 complete circle and 1 partial circle. That tells me this shape is what? A cone. And if I draw the 3D shape, I've got a circle with a point, connect the points. There's my cone. 7 inches is the radius of the base. 12 inches. It's the radius of the sector here. That's also the slant height, because this point right here above this 210 is the apex, and that's going to go from the apex to the outside of the circle, which is the slant height of 12. So let's find the area of the base. What shape is the base in? Yeah, it's a circle. How do I find the area of a circle? Pi r squared. The radius of the base is 7 inches. So pi times 7 squared is 7 squared is 49. So the exact would be 49 pi, but we're going to use the decimal approximation. So I will do pi times 7 squared, and I end up with 153.938, which rounds to 153.94 square inches. So that's the base, the circle. Now I want to find the sides. The sides, here's the sector. Remember, a sector is a part of a circle. How do I find the area of a sector? It's m over 360. That's why the 210 is there. And that's why the 210 is important to us. So it's 210 divided by 360. It's going to tell me what fraction of the circle I actually have here. Times pi times the radius of the sector. And remember, 12 is the radius of the sector. If I want to find the exact answer of 84 pi, I can just type in the numbers with the exception of pi. So 210 divided by 360 times 12 squared, and that's how I get 84 pi. But we're looking for the decimal approximation, so I'm going to take 210 divided by 360 times pi times 12 squared. End up with 263.893, which rounds to 263.89 square inches. Now, how do I find the surface area? It's the area of the base plus the area of the sides. Well, there's only one base, which is 153.94. There's only one side, which is 263.89. Add those two numbers together, 153.94 plus 263.89, and that gives me 417.83 square inches as my answer. And again, if you wanted to do the exact, the exact base was 49 pi, the sides was 84. Add 49 plus 84 to get 133 pi. Example number 4. So they give me the 3D shape. Giving you the net, kind of half drawn out. But so what is it? One circle. Yes, again, it's another cone. Let's label this. 10 inches. It's the radius of the base. So I'm going to put that up there. What's 24? 24 is the height of the cone. And remember, the height and the slant height are not the same. And the slant height is the radius of the sector. But remember, the radius, the height, and the slant height form a right triangle. Here's a mini version of 10, 24 in the slant height. So I can use the Pythagorean theorem to solve that. A squared plus b squared equals c squared. A and b are 10 and 24, so 10 squared plus 24 squared, which is 676, equals c squared. Take the square root. And I did not type the answer in there, but the answer is 26 inches, or c equals 26, which I do have up in the figures here, 26 inches. Well, let's find the area of the base. Again, the base is a circle, area is pi r squared. The radius of the base is 10, so it's pi times 10 squared. If I want the exact, I would just do 10 squared, which is 100. We're looking for the decimal approximation, so we'll do pi times 10 squared. End up with 314.159, which rounds to 314.16 inches squared. Now let's find the sides. Well, the sides is the sector. It's a partial circle. So to find what part of the circle, I'm going to use the fraction m over 360. What's the measure of the arc in degrees, or the central angle? Yeah, it's 150 degrees. So it's 150 divided by 360 times pi times the radius of the sector. The radius of the sector is 26 inches. If I multiply just the numbers together minus the pi, the exact would be 281 and 2/3 pi. Okay, it doesn't come out to be a nice decimal. But if I do that without the pi, so 150 divided by 360 times 26 squared gives me 281.66 repeating, which is 2/3. But I want to find the decimal approximation, so I want to take that and I'm going to multiply that by pi to get 884.881, which rounds to 884.88 square inches. How do I find the surface area? The area of the base plus the area of the sides. The base is 314.16. The sides is 884.88. Add them together. I get 1,199.04 square inches. And if you did want to find the exact base was 100 pi. The exact sides was 281 and 2/3. I get 381 and 2/3 pi. And in this case, actually for cones, the exact and the decimal approximation are both accurate to the nearest hundredth. So that's our surface area for cones and cylinders. Your independent practice, week 8, test 2, is the surface area of cylinders and cones worksheet. Okay? Remember to answer all questions. We're going to ask the same questions on the worksheet that we did in the examples. Name the shape. Draw the 3D shape or net. If the net's given, just label in the measurements. Part of it will be given. Find the area of one base. Find the area of the sides. And then find the surface area by adding them all together. You should write a formula and equation and show the algebra your work to solve it. And make sure you write your answer with correct units. And these are all find an area, so they're all the unit of measure squared. Round all answers to the nearest hundredth if needed, and with circles you will need to round. And then submit it on Schoology. So if you're in week 2, there's the link to the blank worksheet. You can print that out and work off of there, and you will notice the nets. And the nets of the cones do have an X and a Y labeled. You'll see why, because I do want to click on that and show you just briefly. So week 8, task 2, so the questions, so you have to name it. So if I preview this is how you will see it. Name it. Number 1, what shape is it? Okay, number 1's a cylinder. You should draw the nets. I did put a picture. We put a picture of the net in here. What you need to do is label the net. Well, what's the label of X? Well, X is the radius of the base, which is 3. So blank 1 is 3. Do not include units here. Y is the height. What's the height of it? It's 4. Okay. And what is Z? How long is this? Oh, remember that equals the circumference of the base. So if the radius is 3, the diameter is 6, so the circumference is 6 pi. So let's find out what 6 pi equals, and it's 18.85. And then for part C, D, and E, find the area of one base, find the area of the sides, and the surface area, and then what's the correct unit. So each question is asking, now basically you're showing us your work for those. The difference is, as we get to the cones, is again you can do the nets, but there's only 2 measures. What do X and Y represent? Remember, X here is representing the radius of the base. Y is representing the radius of the sector, which is also the slant height. So go ahead and enter your answers in Schoology, submit them. on there. And if you have any questions on any of it, stop in during office hours. As our extension, I've got a cone. Okay, I've got the net here, but I'm missing the radius. I'm missing the radius of the base. So when I want to find the area of the circle, circular base, it's pi r squared. I don't know the radius. Well, how can I find that? That's what I want to do first. So if I go back to my cone net, notice what measurements here were equal. The circumference of the base here equals the circumference of this cone part, which, when I unfold it, that's actually the arc length of the sector. So in order to find the radius, the circumference of the base is going to equal the arc length of the sector, where circumference is 2 pi r. The arc length is m over 360 times 2 pi r. I want to set them equal to each other. So 2 times pi times the radius of the base will equal m divided by 360 times 2 times pi times the radius of the sector, which I use subscripts b and s. If I fill in my measurements here, so 2 times pi, I don't know the radius of the base, equals 225 over 360 times 2 times pi times 32. I want to solve for the radius of the base, the r on the left. So what am I going to do? I'm going to divide both sides by 2 pi. The 2 pi's will cancel out on the right side. The 2 pi's will cancel out on the left side. Leaves me with the radius of the base equals 225 over 360 times 32. If I multiply my calculator, I get what? 20. So the radius of the base is 20 centimeters. So pi times 20 squared. The exact is 400 pi. Type that into my calculator, I get 1,256.64 centimeters squared. How do I find the area of the sides? The sector. It's m over 360 times pi times radius squared. So 225 over 360 times pi times the radius of the sector, which is 32. If I just multiply without pi, I get the exact to be 640 pi. The decimal approximation is 2010.62 centimeters squared. Find the surface area. It's the area of the base plus the area of the sides. 1256.64 plus 2010.62, which ends up being 3,267.26 centimeters squared. If I wanted the exact, it'd be 400 pi plus 640 pi, which is 1,040 pi square centimeters. So that is week 8, test number 2, surface area of cones and cylinders. Thank you for joining in. Thank you for stopping in. It's been great. Guys have been doing a great job. Hang in there. We're almost done. This finishes up week 8. Only 2 more weeks left after we complete this week volume, and then we'll have a quiz to wrap up our school year, and then it's off to summer break. Enjoy. Have fun. This is Mr. Natsky signing out.